think I need to share my screen first. Yeah, thanks for inviting me, Katharina. I am really grateful to speak today. As a scientist, you often find yourself in this tiny enclosed cocoon, but I believe that communication and teamwork are the key to scientific discovery. Um, so I'm extremely grateful to Katharina and also Esther for providing this vital forum. Thanks, guys. Today, I'm thrilled to share insights into my projects on mapping energy seascapes in coral reef ecosystems. This involves decoding the energetic demands fish face within specific habitats using AI-powered 3D tracking and stereo video technologies. Our methods combine real-world observations with AI advancements, all underpinned by an ethical framework, we'll get to that, to responsibly source and use data. My vision for this is at some point we will have a fully autonomous monitoring system deriving ecosystem health information from fish movements. So coral reefs are facing unprecedented challenges from warming ocean all the way to pollution, leading to shifts in ecological balance. Herbivorous fish play a crucial role here, managing algae that can otherwise overwhelm coral systems. But understanding these interactions isn't straightforward necessarily, especially when traditional observation methods limit our scope and depth. But I started out using one of these rather traditional methodologies, stereo video. Here you can see me awkwardly trying to calibrate my system. How it works is the coordinates of these points, so their relation in terms of millimeters to each other dots are well known, and this can be used to then calibrate the systems with known distances and coordinates. And my central idea was to have a look at the feeding behavior and functional traits of surgeonfish in this coral reef environment in Eilat, actually, so Gulf of Aqaba, Israel. And it did work out quite well. So we counted bites and were able to, with the length of the fish, all measured through stereo video, were able to determine feeding pressures and also the two reef fish species that did most of the grazing. So brown surgeonfish and a yellowtail tang. And I was proud of what I did. I actually put this up with the WithSync website. So WithSync is this open access software I was using. And Jason Newswanger, he was so nice as to also share my project. And upon this, Cyril, who's also in the call, approached me and he said, well, we have this algorithm who can identify and track fish in 3D. And I was intrigued. I mean, what can this technology bring to the table? What can I draw from it? In terms, especially in terms of feeding behavior, foraging behavior, functional traits. So the first thing that shot to my head, would it be possible to actually define or quantify the energy these fish need to invest in order to forage on the reef? We were fortunate to get a FSBI, a Fisheries Society of the British Islands, research grant. And with this, we were able to start actually developing our pipeline and adapting Cyril's AI algorithm to this new environment in the Red Sea. We performed synchronized checkerboard calibration in MATLAB and formatted this for OpenCV to correct lens distortion. OpenCV's CV stereo rectify was then used to align stereo images, achieving a reprojection error of less than 1 millimeter, resulting in pretty precise coordinate estimation. And retrained YOLO version 5 model. It's a little bit outdated, but we did this 6 years ago. Fine-tuned on a custom dataset, accurately distinguished fish from coral and other background elements. So moving foreground objects were treated as noise with frame medians used for reliable background extraction. But then actually Cyril and his colleagues, they were asking me, so do you have like a extensive library of identified fish photos, specifically of the two species you want to have a look at. And I was like, well, yes, I have. iNaturalist hosts, this number is slightly outdated, more than 200 million user-contributed, mostly annotated images identified by community scientists. So this is especially handy in data-limited tropical regions, such as coral reef environments in the Red Sea. And if I'm not aware if you know how this works, but so as a community scientist, you upload your image of a fish, for example, in our case, to the iNaturalist repository, and community experts are identifying these organisms, best case scenario to species level. So if we have two matching identification of these photos, this photo is considered research grade. So summing up, iNaturalist offers location-invariant images across geographic regions with the potential to significantly strengthen AI training dataset because our identification are really robust, coming from two, maybe three, or even more community experts. However, we did face some challenges here. For example, the access to this data. So the website does not allow for bulk downloading. So we needed to employ web scraping to download all relevant photos and their metadata. We also needed to apply resolution adjustments to be able to use our photos as training material for our AI, as we shot with GoPros at a resolution of 10,080p. So most of the times, the resolution of the images within iNaturalist are shot with professional cameras almost. So we needed to downgrade our resolutions. And last but certainly not least, license ambiguity. Are we even allowed to use these iNaturalist media? Some of them, but not all of them, with Creative Commons licenses for our AI training purposes, which raised quite a lot of, or in me at least, quite a lot of ethical and legal concerns. So I actually went down this rabbit hole and at the end of the day, formulated best practices in using online media for AI training, which haven't been, or which wasn't established since now. Creative Commons licenses were not designed for AI training. Content creators may be unaware that their media could be used in AI training, and this raises legal and ethical concerns, obviously. Also, data quality. So media from online repositories may lack quality control, potentially affecting model accuracy. And also, the need for standards. There's an urgent need for clear guidelines for using community source media in AI training, as current practices risk misuse, maybe even harm the trust between researchers and contributors. So my advice here, follow FAIR principles. In order to use open media in AI training, ensure training dataset is findable, accessible, interoperable, and reusable with standardized metadata and a thorough documentation to promote transparency. So always upload a spreadsheet with your training data information, along with best case scenario, the code of your AI model. If there's no CC licenses in place for the particular media you'd like to train your model with, then you need to ask for permission. Two things here. So if there's CC licenses in place, you need to publish also. So the content, the name of the content creator and a link to the file, and also which CC license the media is under. This really complicates things because if you want to publish your AI model under CC BY, for example, you cannot use media. At least you can challenge me on this because I think it's an interesting point of discussion. But in my opinion, you are not allowed to then use media for training purposes, which are licensed under CC BY share alike, for example. So you really need to be careful with which training media you're using. And if there are no CC licenses in place, then you have to ask for permission. This is not easily done, and especially not if you are dealing with training data, where you would have a lot of data in order to have a robust AI model for, in our case, species identification. So you would need to ask a lot of content creators for their permission to use their media. So my advice would be that researchers should closely work together with repositories, online media repositories, such as iNaturalist, for example, to provide these protocols and provide easy access or easy pipelines for us as researchers to ask for permission to get these, to use this media for AI training, maybe even write this down in the terms of use. So just in short, you need to attribute the media or the content producer, but also I would also go ahead and contribute the people identifying the organisms. And by the way, since this will be published on YouTube, if you know which images, like licenses-wise, iNaturalist is using to train its own AI, please leave a comment, because I couldn't find this out through their terms of use, and I would be very interested in whether they use CC license material to use their or to train their own model. Where was I? Sorry for this short detour. Summing up, we augmented our convolutional neural network using iNaturalist, diverse community contributed images, applying transfer learning with location invariant images. Resolutions were scaled, and k-fold cross-validation was employed to ensure accurate, generalizable fish classification across varying environments. After detecting fish, bounding boxes were paired across stereo images, allowing for triangulated 3D measurements of fish size and position. Using deep sort, you can see here, we tracked individual fish across frames, maintaining identity even through occlusions, to document comprehensive movement patterns and behaviors throughout the video sequence. And our trajectories look more or less like this. And our model looks like this. So AI-driven object recognition, species classification, which is not shown here, unfortunately, and 3D tracking. And this is what a typical AI-derived XYZ trajectory looks like. And I wanted to harness actually the ability to have a look at variations in velocity. Because I know from literature, this has been done since 30 years already, that a variation in acceleration of organisms is directly related to their energy expenditure. I've been told by physiologists that measuring field metabolic rates is pretty much the holy grail of physiology. I was intrigued if we could do this with AI-derived trajectories as well. So my research question was, can we determine how much energy one fish is spending during its presence in our video material? And we used actually data for surrogate species from literature to scale up this is called overall dynamic body acceleration, ODBA. So acceleration data with metabolic rate, site-specific metabolic rate data from literature, and were able to not only measure velocity in the two species of surgeonfish, but also then infer field metabolic rates or rates of energy expenditure, which gives us the ability to ask entirely new questions or uncover entirely new energetic trade-offs. For example, we did see that the yellow-tailed tang here on the right side, Zebrasoma sanctorum, did exhibit significantly higher inter-bite distances, even though energy expenditure in both species remains the same. So we did see that energetically wise, Zebrasoma sanctorum, so sorry, yellow-tailed tang was moving more efficiently. But one drawback, my initial idea was also to conduct a behavioral analysis with the continuous trajectory data of the fish, which didn't work out as planned, as it was just a little bit too noisy. I had the chance to go to the Solomon Islands. This is Colombagara Island, right in the Western province. And we set up our stereo video racks there. So due to decades of logging, we find a pretty steep turbidity gradient right on this reef in Bavanga village, or in front of Bavanga village. And parts of this beautiful, beautiful natural turbid reef have now transformed into an anthropogenic turbid reef. So we now wanted to know whether energy expenditure would be different in these degraded or healthy versus degraded environments. And as you can see here, calibration went a little bit more smoothly this time, with a little bit more grace, especially from my master student, Emily. And I had a human intelligence this time around working on tracking the fish. Unfortunately, we were not able to make use of the full 60 frames per second temporal resolution, but we sampled every 6 frames, so we have 10 observations per second only. But our 3D trajectories, which you can see here for a Eastern Triangle butterfly fish, are much smoother, so we don't have as much noise. But same thing again, along this turbidity gradient on the reef, we modeled energy expenditure, field metabolic rates, and here you can see on the x-axis visibility as a proxy for turbidity, and on the y-axis field metabolic rate. And for all 3 species we run our analysis on, so far we do see a significant difference or a significant decrease in the energy they need to use with visibility. So at lower visibility, high turbidity, they spend a lot more energy on just foraging or moving when compared to almost pristine condition and very clear water with high visibility. And also, for this time around, we were able to conduct behavioral change point analysis, behavioral modeling of the entire trajectory. And we have now trajectories for several hundred fish along this entire gradient. And this is the next thing that we will explore to see whether we see differences in their behavior using a standardized approach. And as I said, my overall goal is to construct these energy seascapes. So 3D models visualizing the cost of movement for fish. And hopefully we are able to develop a system that is autonomously able to record, identify, track, and even extract energy expenditure for fish, but maybe also behavioral dynamics of fish with relation to, of course, ecosystemic stressors and ecosystem degradation, perhaps even. So in the end of the day, we will have a system that can help us evaluate the health of an ecosystem like a coral reef. Yeah, to be able to adapt our stereo video and AI-driven tracking approach to the Solomon Islands, the next step would be to yeah, apply for funding, as you all might very well be aware of. The hardest part of being a researcher, to now try to leverage these findings and scale this up to ask even more pressing ecological questions. This is actually a part I'm really, really happy about, because this is my project team, and I was able to bring together colleagues from New Zealand, Germany, and France, which I'm extremely, extremely happy and grateful about. Especially my students, Emily, Michael, and Hussam. Thank you guys very much. This has been an awesome ride with you guys. And yeah, thank you guys for attending today. And the floor is yours, open for questions. Thanks, guys.
Thank you so much, Julian. It was great. Yeah, it was a great talk. Yeah, it's a very useful framework. I have a few questions, but maybe I'll leave other people to ask first. Uh, Please go ahead and unmute yourself and feel free to ask questions to Julian. If or I can start as well if no one has. Yeah, maybe I can
I
start.
guess you're shy.
So I was wondering, so the first question I had actually was about the resolution when you extracted the images from the iNaturalist platform.
Yes.
And you mentioned that you downgraded the resolution, lowered down the resolution of some images. What is the rationale for that? Is to keep all the images at the same like consistency, same?
No, we were shooting at a resolution with our GoPro cameras, that is. We were shooting at a resolution of 1080p HD video. And if you have the, I mean, um, if you have the videos or still frames of our videos, their resolution is not very good. So it's very pixelated, and if you want to identify the fish from this now pixelated image from a HD glossy image, this is not possible. You need to have um, the resolution, and Cyril might be able to correct me on this, but you need to have a resolution which is comparable to the one you find in your videos. Now, to deal with this, I would go ahead in the future and try to aim for higher resolution videos to get also higher resolution images or videos of fish in situ. Um, but yeah, one approach that worked quite nicely for us was to downscale the resolution of fish. Also, we needed to cut the images when there were several individuals of one species in the photo. We needed to cut them down for it to just be one individual to be um, um, to function as training material for YOLO.
Yeah, I see. Thanks. Does anyone have questions?
I'll jump in.
Hi, Ben.
My name,
Thank you.
hi, my name's Ben. I'm a researcher in the United States, and I work mostly on fish in small streams, so very constrained habitats. And the interesting thing is most of the fish have dot patterns that we can use to identify
Mhm.
individuals. And it seems like you can't do that with your fish. Is that correct?
So the way the tracking algorithm works is even if there's occlusion and the fish is lost from the view, the fish individual is then identified and tracked again afterwards. So I'm not particularly an expert on this side of the algorithm, but it should be possible if trained with the information from the individual, I guess that's how it would work, then it should be able to pick up the exact same individual again.
Yeah, that's something we've been working on with Wild Me a little bit.
Yeah.
If you're familiar with that, but we haven't gone to video. And I'd love to bring those two worlds together, the individual identification with the video and the behavior.
Yeah, have you seen it's an X project of Google or something with the salmons just swimming towards the
Yeah,
camera and each one is identified individually? Yeah, I know this is possible and it should be possible in with this as well. But yeah, I mean, one thing I've learned is there's a lot of work involved and uh, working interdisciplinary between computer scientists and ecologists is also kind of tricky. Um,
yeah,
because computer scientists are interested in making it work, whereas the ecologist is interested in making it work robustly and generating like a robust set of plentiful data. um, yeah, I'm also very much interested in getting this approach to a level where it's easily used.
Yeah, so if anybody's, I'm about to enter a second phase of my career, so I'll have time. So if
Yeah.
anybody's interested, I'd love to think about maybe we could do a joint NSF, US NSF, European Union proposal, something
What
like
what
that. I'd be
what
happy.
species are you working on?
It's mostly brook trout, but
Ah,
it's any kind of salmonid. Anyways, be
there's an
fun to
yeah,
talk about.
nice to meet you anyway.
Yeah.
There's another question in the chat. This is why I was distracted. Sorry, Ben.
Yeah, that's yeah, no,
Just greetings
yeah, yeah.
from Macedonia, nonetheless.
She also doesn't have the microphone, but she's congratulating you on very interesting presentation. Yeah, so I think just regarding Ben's suggestion, I think that's a great opportunity, for this with this consortium. We could also create a working group or something similar on that topic. And yeah, I think to join efforts to different researchers on that area. Yeah.
That is true. And
Yeah.
if we are looking ahead, we need to build systems that are easily adaptable. And this is also something that I've learned now that it's, even though they are coral reefs,
Yeah.
you always need to pretty much start from scratch in adapting the model to a new environment. I mean, there's pre-trained algorithms, of course, and you build upon your existing model, but then you throw it into a completely new environment. And yeah, it would be, well, I mean, it would be awesome to have a system that works in blows like river systems and also the coral reef and doesn't need to have a lot of adaptation. Um,
Mm.
guess that's
Yeah.
something on the application side that could be even further enhanced. Yeah.
Mhm. And on that line, maybe you can share with us as well later after the a link to the framework that you've used for
Yeah.
this. So it's because it's available as well, right? On
Yeah, I forgot to mention this.
yeah.
I forgot
Yeah.
to mention this. So what I touched upon now, yeah, the entire description of the framework of the pipeline is available in my publication in Ecology and Evolution. And also, Cyril has put out a brilliant a preprint on Archive, where he's going into more detail even on fish measurements and identifying fish. So yeah, I mean the two, my work is really built upon Cyril's quite a lot. So yeah, I can. How may I share it with you guys? I can
Oh,
send
maybe you
around
can
an
share
email
and I can
perhaps.
add it to the websites. Yeah, yeah,
Yeah,
or that. Yeah, yeah. Yeah, sounds good.
because both links, both studies are online, freely available, and even the code is online. So if you guys want to dig into that, you're more than welcome.
Yeah, thanks. Any more questions? I have another one as well.
Yeah, sure.
And and Jose Fernandez is here as well. Is along the lines that we've discussed before as well on data, on the importance on data validation, but from completely independent data sets. So I'm not familiar with how these methods traditionally are done, how the fish metabolic rate and like the fish trajectories and fish metabolic rate is estimated using traditional methods. But do you think it's possible to compare, to have the data set with a traditional method and using your approach with automated tracing and just to have it as an independent validation and compare
Yeah,
how well it performs compared to traditional
um,
methods?
it's tricky because um, especially for aquatic organisms, it's not easy to measure metabolic rates in the field. So what you do is you have them in a chamber, and you measure their standard metabolic rate and you measure their maximum metabolic rate. So how much oxygen they're consuming in a matter of time, right? But it is not easy to do this in a real, in our case, coral reef environment where the fish is stressed or foraging or reacting to other individuals and so on and so forth. So what has been done is exactly using acceleration as a proxy for energy expenditure. And in my case, I'm outlining this in my publication. We are using acceleration plus scaling it up with standard metabolic rates measured in the lab to be able to infer energy expenditure in the field. And I don't know of any methodology that could be directly used to compare or to falsify my energy expenditure measurements. What I know and what I tested my own results against was the maximum metabolic rate or the metabolic scale, whether my values would fit into the metabolic scale of this particular fish, and well, they did. Otherwise, I would have not dared to publish. But so I'm quite confident they're in the same ballpark at least.
Yeah, thanks. Yeah, that's
Yeah, but they can be compared. As I said, they can be compared with the metabolic scale within either surrogate species or the same species even. So we do have a measure of whether these whether the data we get out of is realistic or not.
yeah. I'm just thinking maybe the behavior part of it will be easier to compare with the, with the manual in-field data, because if you have a, diver measuring in the, manually the behavior, and then you infer it from a model, you can have an independent validation data set in that case. But yeah, in the metabolic rate case, it's it's harder.
I mean, in this case, we can also do manual measurements of fish, as I have shown actually. So we could run AI against fish or manually derived trajectories in order to infer energy expenditure. For the behavior, it is tricky. Yes and no. So I also learned quite a bit from this experience, and I think especially what is it called? Ground truthing of your AI results is quite important. And I would always go ahead and pay much more focus on ground truthing, especially with behavior. But I have to admit that the behavior model, like we are trying to run it, it really picks up on tiny nuances. So it will be interesting to see whether we are actually able to see and quantify behavioral changes manually when compared to what the data is showing us from, or the model we will be using behavioral change point analysis. So it is using differences in X, Y, Z coordinates and concerted changes in these coordinates. So it will be interesting to see, as I said, whether we be able to manually see changes in the fish's behavior as opposed to the quantification of the algorithm.
Yeah. Looking forward to that one as well.
Yeah, that would be interesting. I've been working on this for quite some time with actually a dear colleague of mine, Jingjing Zhang, who's a movement ecologist, and we are now elevating behavioral change point analysis, which is usually done on GPS tracking data, now on a 3D scale. And this works, so far it works quite good. And yeah, there's definitely more to come.
Nice. There is also a comment from Jose Fernandez. Maybe can be at least compared with literature rates to see if it's within what expected. I guess that's what you've done, yes.
Yeah.
In the
some answer to that already. But
Yeah.
yeah, of course, I would suggest this to any researcher. No matter what data you get, always try to find literature data whether your data makes sense at all. Compare it.
Yeah, very important. Any other questions?
Julian, thinking a little more about metabolic rate, in our fish, they have pretty big mouths and you can look at breathing rates, and we've wondered about estimating breathing rates. It looks like your fish have little tiny mouths. Have you thought at all about trying to look at breathing rates?
No, I've been looking, but I mean, I would regard it as a functional functional trait, perhaps. So these fish are biting, and what we did try to quantify is bites.
Yeah.
Using computer vision, right? It's really not easy. It was just a side project of my student, but this would be the next step actually to try to quantify functional traits, like perhaps mouse breathing, the movement of opercula or the mouse, and in my case, because I actually had a student who recorded all the bites, and it would be, which is especially in coral reef ecology, a highly important functional trait to measure because it tells you so much about the health of the ecosystem and how effective the surgeonfish, as the grass mower of the coral reef, are performing their functional role. In your case, it would probably make sense in order to tell something about oxygen consumption. So
Right.
there's a lot of possibilities for future AI or computer vision applications to pick up on these functions or functional traits. Yeah.
Yeah, it'd be great.
Any other questions? Well, if not, I think we can leave
Yeah,
it
so
here. Yeah, Julian, yeah, if you have
So
anything.
there's actually several aspects of analyzing continuous data I'm trying to following. So I mean, determination of functional traits is one, but and behavioral change point analysis would be another one. So there's this statistical aspect of trying to make sense of this continuous movement trajectory, but also trying to employ computer vision then to pick up on even more information you can gain from your videos. I think this it's also something that defines my work to try to make the most out of your data at hand, right? Because I started out with this while being frustrated with just getting the means of everything, and now I actually ended up calculating the mean energy expenditure for each individual fish. But I'm still actively trying to draw conclusions from more than just mean calculation from the entire trajectory from the entire data set. So yeah, this has been a long focus of mine, and Ben's comment just reminded me of that there's so much information in recorded videos that we just need to find the means and the research questions also to work on this.
Yeah. Well, yeah, thank you so much, Julian. It was a pleasure to have you. And I
Thank you
think
very much for your time.
we can continue the discussions and you know, on our consortium meetings and through the chats from the website that we have as well, if anyone has other questions. Yeah, thank you so much, Julian.
Yes, thanks guys for inviting me, and yeah, I'd be very much interested in contributing further. So I'm happy about the invitation and about the opportunity to showcase our work. Thanks guys for attending.
Thank you.
Bye bye.